Hello friends, welcome back. In this tutorial we are going to discuss about scalars and vectors. Now let's start. Scalar is a property which has, or I can say represents, only magnitude. Scalar is a property which has or represents only magnitude. Now magnitude means you can think like a number, a single number. Let us take some examples so that you guys can understand. Length, L-E-N-G-T-H. Length is equal to 60 meters. Now length is 60 meters. It says that length is 60 meters. 60 means magnitude. Understand this? 60 is magnitude. Now it represents magnitude, but it won't say in which direction the length is 60 meters. Whether it is right 60 meters, whether it is left 60 meters, whether it is upward 60 meters, no idea. But it says that, yeah, the length of this is 60 meters. That's it. That is what it says. Another example, H-E-A-L-T-H, health. Health is equals to 100%. Now health is 100. It is telling that the magnitude of health is 100, but it is not telling in which direction the health is 100. One more example, visible. Visible is a Boolean value. It takes either 1 or 0. That means its magnitude will be either 1 or the magnitude will be 0. So here the magnitude will be either 1 or 0. It indicates that either the object is visible or not visible. That's it. It won't say in which direction it is visible, in which direction it is not visible. Another example, temperature. Temperature of a weather or temperature of a water, if you are considering. Maybe you can say that 50 degrees Celsius. The temperature of water is 50 degrees Celsius. It says that it is 50 degrees Celsius. But it won't say in which direction the water has 50 degrees Celsius. One more example so that you guys can understand. I hope you guys will understand. Take the color. Color is red. Now it says that the color property of the game object, let us say, is red. But it won't say in which direction it is red. Another one is speed. You are driving a car and somebody called you and asked at what speed you are driving a car. You might be saying that 80 kilometers per hour. When you are saying that 80 kilometers per hour, but you are not telling there in which direction you are driving your car at 80 kilometers per hour. Now that 80 indicates the magnitude. Usually we represent scalars by a line like this. Take here it is 0, this is 0 and this one is 100. I am representing the health of a player. I represent it by a line and the length of this line, length of this line is 100. You can say from this direction to this direction also 100. From this to this direction also it is 100 only, right? If you measure by using a tape from this direction to this direction, then it will be 100 only. If you put the beginning of the tape here and measure in this direction, then also the length will be 100 only. Now here later the health has got reduced. Let us take somebody hit the enemy and its health got reduced to 50%. Now I can represent that health by reducing the length of the line to 50%, right? Now the length of the line now is 50, guys. Now this indicates that it is having the magnitude 50. Length means magnitude. Are you guys understanding? Or distance means magnitude. The distance you can say as a magnitude. But it won't say in which direction. There is no direction involved. Now when you come to vectors, you are going to have direction involved, my friends. Let us see vectors. What is a vector? A vector is also a property of your game objects, is a property which has or represents both magnitude and direction. So vector has a magnitude, that means it is going to have a length as well as the direction involved in it. Now as I told, how do we represent a vector? Okay, representation of a vector. Of course you can represent a vector by a line. Of course this indicates the length of the vector, guys, or the magnitude of the vector. Plus the vector is also going to have a direction, so it is going to be a directed line. Whereas scalars are not directed, whereas vectors are directed lines, you can see. If I consider this one as a y and this one as a x-axis, here you can very easily say that here you have x-axis, x is equal to 1, y is equal to 2, x is equal to 2, x is equal to 3, x is equal to 4. Now can you tell me the length or the magnitude of the vector, guys? I think you can say very easily that it is 4 meters, sir, right? It's 4 meters, correct. Now can you say the direction, guys? Now direction is right direction. It is looking towards right, correct or not? So it is right direction, R-I-G-S-T, right. Now you can see now it has direction. Now how do you represent the direction of a vector? Very simple. The angle of the vector indicates the direction, guys. Now here the angle of this vector is 0 degree, right? This is 0 degree, right? Indicates 0 degree. Whereas here you have 90 degree, right? Here you have 180 degree. Here you have 270 degree. And here back 360 degree. Let's take the same vector. Let us take the same vector I can take if I want. Let me take this representation little up so that I can move it little down. This indicates the down vector, D-O-W-N, down, a down direction you can say. This indicates the left direction, and this one is a up direction. Or you can say north, south, east, west. You can say like this vector is looking towards east. Now same vector, let us take the same vector. If I draw like this one is a 1 unit, this one is a 2 unit, this one is a 3 unit, this one is a 4 unit, and the vector is looking towards up. Now you can say me that, sir, the magnitude is, how much is the magnitude, guys? 4 meters, that is correct. But the direction is up. Understand? How you can say it is up? By saying its angle, theta. Theta is 90 degree. When it is 90 degree, you can say that the direction of this vector is up. Or you can say it is looking towards north. It is looking towards up. Up vector we say. This one is a right vector, this one is a up vector. Here you have the direction as well as the magnitude, guys. I hope you guys are understanding clearly what I am talking about. Maybe you have a vector something like this. Maybe you have a vector something like this. Now here you can see its direction is different. The direction is different. Even the length is different. You can see that. This is the length. You guys understand? From here to here, it's the magnitude, and the theta, the angle, that indicates the direction in which the vector is looking. In mathematics, we represent the vector in this way. We say if this is a v vector, then I can say there is a vector called as a v, like this, and it has two properties. One is the theta and another one is the magnitude. You can represent a vector by using theta and magnitude. Another way of representing the vector is, usually vectors are going to join 2 points. Let us take this is a origin, that is a point, we know that. And another point is over here, just at the tip of the vector. These are the 2 points that I can use to represent this vector also, right? I can represent this same vector by using 2 points, that is the P1, that is the origin. Another one is a P2, that is the ending. Now you can represent this vector's angle. You know how to find out the angle if you have 2 points P1 and P2, right guys? Just you need to calculate the x distance, y distance and find out the angle. That gives the theta. And you also know how to find out the magnitude of this vector. If you have 2 points already given, it is very easy, right? X square plus y square, you have to use the Pythagoras theorem to find out the magnitude. This is another way of representing the point in math. You can even represent a vector in a simpler way, just by giving the x and y values. And these x and y values are actually this point, or a point which is at the head or the tip of the vector. And you can consider the another point, the origin will be always 0, 0. You can think like that. So we just give the x and y values that indicates what is the position or the point at which the vector head is pointing. This P1 is a tail, guys. This P1 is the tail, T-A-I-L, tail point, and this one is a head point. So in this place, these x and y indicate the head point x and y values, whereas the tail will be always represented as 0, 0. That means at the origin. I hope you guys are understanding step by step what are vectors, how do we represent vectors. In simulations or games, you can follow anyone. If you know the theta and magnitude, you can very easily find out what is the tail and what is the head. But we will be following this vector representation. We are going to follow this one because the Unity follows this one. To represent the vectors, we use Unity's vector 2 structure, and to represent the 3D vector, we use vector 3 structure from the Unity. And we are going to understand this. How do we create vectors and represent the vector and find out the angle, magnitude, all other things. Step by step we are going to get ideas, guys. Now what is the responsibility of vectors? Next thing, why vectors? Vectors are mainly meant for or having the responsibility of placement and movement of game objects is the responsibility of vectors. Whenever you are placing a game object on the scene, always think that you have a vector there. Whenever you are moving a game object in any direction, that means there is a vector involved in it. Behind the scene, the vectors are not visible, but they are always available in your game scene or your simulation project. Always vectors are available behind the scene. In our real world also, we are surrounded by many vectors. Now let us proceed and let's check it out what else we can do. Now as I told that the vectors are responsible for placement and movement. Actually vectors are responsible for movement of the object. I am especially added this term called as placement because it is easy for me to explain you guys. I have added that. Let's proceed and understand about movement. Movement, or we say motion of objects. We are going to discuss about movement or motion of the object. So as we are discussing about the motion or a movement, now we will be working with in a 3D world. We will be working a 2D or a 3D simulations working with. Now here, whenever we are working, we usually use the Cartesian coordinate system where we will be having x-axis, y-axis and z-axis, which help us to place an object on the 3D world or a 2D world, and we can say x, y, z are used for the movement of the object. So x-axis, y-axis and z-axis we will be having. Now when we are discussing about the motion or a movement of the object, we will be having three different ways of movements of the object. They are motion in 1 dimension, motion in 2 dimension, motion in 3 dimension. Now when we discuss about motion in 1 dimension, what is the meaning of that? We restrict or put a constraint that you can move in only 1 direction. You cannot move in 2 directions. Or you can say that motion in only 1 axis, I can say. Movement in only 1 axis. Let us take an example there. When we discuss about motion, actually if I am using the x-axis for the movement of the object, I will not use the z-axis for the movement of the object. That means we set the y and z-axis, we make them invisible so that we constrain the movement of the object only in x-axis. That means when you have x, y, z, we are making something like this, guys. We make x, we set y equal to 0, z equal to 0. Now here what happens, we have constrained the movement of the object only in x-axis. So we set the x as a variable, or we create x as a variable Whereas y will be always 0, z will be always 0. When y and z are 0, you know that the object, if x is also 0, let us take, then the object will be over here exactly at the origin. Correct or not? Here, if you place the object in this place, x will be 0, y will be 0, z will be 0. Right? And you are not moving either up or down, either front or back. Z indicates moving front or moving the object back. Now here, the object is at present at the origin. This one is 1 unit or 2 unit, this one is -1, this one is -2 units, right? -1, -2, 1 and 2, let us say. If I have to place the object here, right, I just need to set the x is equal to 2, y is equal to 0, z is equal to 0. If I have to place the object over here, then I have to say x is equal to -2, y is equal to 0, z is equal to 0. You can see that you are moving the object left and right, but you cannot change the values at y and z. They are always zeros. You have constrained, you have put a rule that you cannot move the object in y and z. That is known as motion in one dimension. You can use any axis for motion in one dimension. That means you can either move in x, or you can move in y, or you can move in z. If I constrained the motion in z, I do not want to move in z, I constrain that z will be 0. I constrain the object should never move in left or right or on x-axis. Now you can see that if I say x is equal to 0, y is equal to 0, z is equal to 0, we know that the object will be over here. And here we are constraining the object by x is equal to 0, x will be always 0, whereas y you can change, y is a variable, z is 0. Now this time, if I say y is equal to 0, x is equal to 0, y is equal to 0, z is equal to 0, object will be here. Here I can have 1, 2, here I can have -1, -2, right? You can have -1, -2, -3 down, 1, 2, 3, 4 above, right? That we know already, Cartesian coordinate system, mathematics, right? Now if I say 0, y is equal to 2, then of course the object will be over here. If I say y is equal to -2, x is anyhow 0, z is anyhow 0, the object will be over here. This is known as motion in one dimension, guys. Only in one direction you can move. You can use only one axis for movement. Now take another one. If I constrain now, I cannot move in up or down. We can move only front or back. Front means inside the computer, out of the computer screen is back, guys. That is how the unity also works. And here we are constraining the movement to x will be 0 always, y will be always 0, and it is going to have the z value. Z is a variable which you can change according to your requirement. If z is 0, the object will be over here. If z is 1, 2, let's say -1, -2. If z is 2, then the object will be over here. X and y will be always 0. This is known as motion in one dimension. You can place any object at any place, or you can move the object next. Usually we will be working either in motion in 2D we will be working with, or we will be making the object move in 3D world. That means we will be making simulations or games either 2D or 3D. So we will be following these things. And actually we will be always working with x and y for motion in 2D. So z will be constrained. We won't consider z. Z will be always 0, guys. So you can say here this one is x, y variables you will be having. Z will be always 0 if you constrain. You can use any other planes. If you want, maybe let us take an example that you have constrained x. You do not want to move the object in x, and you want to use y and z planes for movement. Maybe you want to constrain y movement. You do not want to move the object in y. You want to move only x and z. Now here is the 2D coordinate system. There you will be finding something like this, right, my friends? X, y, -x, -y. Now here you can move any direction on a xy plane, x-axis, y-axis. You can place an object over here. If you say x is equal to 2, y is equal to 0, z is equal to 0. Let us say. If you say x is equal to 2, y is equal to 2, then the object will be over here. If you say x is equal to -2, y is equal to -2, object will be over here. You can move simultaneously on x axis and y axis. Whereas if you constrained the x movement, that means x will be 0, y will be variable, z will be a variable, you can change the y and z. It looks something like this, guys, right? It looks something like this. You are moving on a plane, there you have in and out facility. Now here you can place the object anywhere you want according to your requirement. I'm just talking about the movement, guys. Now here you have the movement in z plane, right? You can move the object front or you can move the object back. You can place anywhere on the ground. So when you come into 3D, you will be usually working with xz planes for movement of the object, guys. Now here we are in 3D. Now when you are working with 3D, here there is no constraint on movement of x, y and z of the object. You can move in any direction. I hope you guys are understanding. So here you can change the x, y, z and place the object anywhere you would like to. I'm just drawing so that you people can understand what is x plane, what is y plane, what is z plane. It will be much more interesting if you know these things. Right, guys, this is a zx plane, this is a yx plane, right? And also you will be having another plane which might look a little different, right? Something like this, which is meant for z and x. So like this you will be having planes. These are known as planes. The x, y and z will be infinite, guys. The planes are infinite. Let us take an example that if I want to place an object in the 3D world, then I can say x is equal to 2, y is equal to 2, z is equal to 2. x1, 2 here, and y1, 2 here, and z1, z2 here. So you will be drawing a point on the 3D world somewhere here. It looks like this, guys. I hope you are understanding what is the meaning of motion in one dimension, how we implement it, motion in 2 dimension. Usually we work in xy planes where the z will be constrained for 2D, and 3D will be like this. You are not having any constraint. You can move or place object in a 3D world anywhere. There you will be using x, y and z values. So as we are working with the xy or xyz, we represent our vectors by using the simplest form where we will be telling the object position by using xyz that indicate the head of the vector, So I can draw a vector from here to here and say that this is a place the object is at x is equal to 2, y is equal to 2, z is equal to 2, and the tail will be 0, 0, 0. Very simple. And then we can calculate the angle and length, other things we can do. Right. Let us proceed and get some examples that you might find in games most commonly. Some examples like position is a vector, guys. Position you can represent if it is a 2D px, py, if it is a 3D px, py, pz, right? Position vector, you will be finding velocity vector, like movement of the object if you are doing. Definitely we will be creating a vector which is known as a velocity vector. Acceleration, ex, ecc, elerati. Acceleration is a vector, guys. Then force is a vector. Then other vectors are there like friction, friction, friction in x, friction in y, friction in z, force in x, force in y, force in z. Acceleration in x, acceleration in y, acceleration in z, velocity in x, velocity in y, velocity in z, position in x, position in y, position in z, and torque, T-O-R-Q-E. Torque is a kind of a force, rotational force we say, and that is also a vector we represent. Then weight or gravity, gravity, gravity comma weight, weight, they are also like gravity is a acceleration which we represent by using the vectors. The weight of the object, that is also a kind of a force, we represent it by a vector. So there are few most commonly found vectors I am just talking about.